So on the last test, the test of chapter 7, the test for chapter 8, I'm sorry. There was a similar question where you had to fill in the missing values for the table, and then we wrote the function for just one of them. This one, I'm asking you to do both. So there's two different tables, the one for A and B, and you're asked to write the function for A and then also write the function for B. So it's a little tricky, but when I look at this, I'm going from 7/8 to 7/4, and the question is, oh my gosh, what am I multiplying by there? Well, I'm a little older and more experienced in the ways of mathematics, and I look at it and I can see, well, what I've done is I've put a factor of 2 in the numerator, right? So for example, if I have 7/8 and I multiply by 2, right? What is that? That's 14. I can simplify this. I can write it like this: 7 times 2 over 4 times 2, and you can see there's a giant 1 here. So when I multiplied by 2, right, or I could say by 2 over 1, I end up getting 7/4. So what's happening is I'm doubling this each time I move forward. Another thing you could do is, if you're not sure, is you can always take, if you suspect that it's a linear function, I'm sorry, if it's a geometric or an exponential function, you're multiplying each time, you can take a like this term, right, 7/4, and you can divide it by the previous term. I can divide it by 7/8, and the result of that is the multiplier. And if you remember a lot about how we deal with division in terms of rational numbers, right, fractions, this is equivalent to 7/2 times 8 over 7. And you can see, if I write this out, right, I've got a 7 times 8 over a 2 times 7. So there is a giant 1 here in the form of 7 over 7. So that's gone, and I'm left with 8. Uh-oh. I'm left with 8. Oh, this wasn't a 2 in the original problem. I'm sorry. This is supposed to be a 4. This was a 4, and this was a 4. Yeah, so I can take this 7/4 and divide by 7/8. And when I do that, I get 8 over 4. You can see there's an 8 over 4 here, which is equal to the number 2. So I'm multiplying by 2 each time. So saying that, what's the next value? If I multiply this by 2, it ends up becoming 7/2. Multiply that by 2, it's a 7. Multiply that by 2, it's 14. Yay, 14. Multiply that by 2, and it's a 28. So you can see each time my multiplier here is the number 2. I'm multiplying by 2. And my 0th term is 7/8. So if it's an exponential function, that has to be y equals 7/8 times 2 raised to the x power. Pretty straightforward. Be careful with this. Don't write this as 2x like that, because it's not 2 times x. It's 2 raised to the x power. So as I move forward, I'm multiplying by an additional factor of 2. So that's the answer for A. For B, some big clues here. Like if I'm going from this right here, 15 to 9, 15 minus 9 is the number 6, I believe. And the other thing is, if I did this, if I did -3 minus 9, that would be the same as -3 plus 9, which is the number 6. So either way, you can figure out what you're adding each time by taking a term in the future and subtracting the previous term. And when I do that, when I take 15 and I subtract 9, I get a positive 6. And yeah, moving forward, 9 plus 6 is 15, and -9 plus 6 is -3. -3 plus 6 should be 3. 3 plus 6 is 9. And then -9, if I'm going to go backwards, -9 minus 6 would be a -15. Then I could test it going forward. -15 plus 6 would be -9. So I'm moving forward by adding 6 each time. And this is a linear function, right? This is a line. So I would show that as 6 times x. So every single time x increases by 1, I'm adding an additional 6. And some of you, I know, are still looking at this and like, how the heck can you say, Mr. Roberts, that you're adding an additional 6? Because it looks like you're multiplying by 6. Let's write the -15 down here, because that's my 0th term, and then talk about that, right? So again, when we use multiplication, it shows repeated addition. So think about this. If x is the number 1, I get a 6. If x is 2, I have 2 6's, which is a 12. If x is 3, that's 3 6's there, which gives me the number 3 times 6 is 18. If x is 4, I've got 4 sixes, which is 24. As I move forward, each time I'm adding an additional 6. So there's 1 6, and then a 6 plus 6, and then a 6 plus 6 plus 6, and then a 6 plus 6 plus 6 plus 6. So again, multiplication is used to show repeated addition. I'm adding 6's each time as I move forward. And my 0th term, you can see, is the number negative 15. So that's it for question number 6.